Hi there, this is Barrett from C4, Cypress College Cyber Club. In this video walkthrough today, I'm going to cover Lab 1, part of the Security Plus lab series. This is about network devices and technologies, capturing network traffic. And it covers Objective 1.1 of the Security Plus exam. So it will be great review for anybody looking to take that certification in the future. So if you have this PDF walkthrough, you'll see in the table of contents, it covers the three different sections we'll be going over in this video using tcpdump, using Wireshark. They're both network analyzers, so we'll use those to capture network traffic using this Linux sniffer that is residing within the network topology. Also, always a good idea to go over the objectives in these lab walkthroughs. It's you want to get familiar with the terminology of the tools you'll be using. That way, as you actually work on the lab, you'll have a better understanding of what you're doing. So, taking a look at the topology here, we have an external network and an internal network. Both have different types of machines. The external has two machines, a Backtrack 4 running Linux, a Windows 2K3 server, and on the internal machine we have another Backtrack 5 machine, which is also Linux, Windows 7, a Red Hat Linux machine, which is typically used for servers, and a Windows 2K3 server machine. And in between that we have a firewall, also known as a gateway, and the Linux sniffer, which is going to be capturing packets that are being sent between all of these machines. Now, the very first thing, especially in this case, because we're capturing data throughout this network, we want to make sure that we're logged into each one of these machines before we begin doing anything. So we can go ahead and do that. You see all of the login details are listed here. In most cases, the password is actually password. Okay, so we'll go ahead and start getting logged into these machines here, starting with the root, starting with the Backtrack 5 machine. Of course, you always want to do start X, which is all this is detailed in the PDF walkthrough on how to launch these machines. Let that boot up. Password. This is the Red Hat Linux machine. Now, on when you're in the lab environment, you can't press Alt-Control-Delete on your actual home computer. So you'll actually come up to the drop-down here, and you'll send this command. And we can enter the password. Come to VM5. This is actually the firewall, so that's already logged in. Oop. Sorry, this one is, the password is TOOR, root backwards. Almost done, last machine. And in future labs, I don't believe you have to launch quite as many machines, but like I said, because we're capturing the traffic of this entire network, we need to have every machine booted up and logged in. Okay, great. So we navigate back to the topology here. And these next few pages, you're going to see these are just the close details of all of the login instructions, what I just did there. Okay, so now we are ready to get started on this lab. The first section is going to be using tcpdump to capture network traffic. So we want to log into the Linux sniffer, which we already logged in. That's VM6 here. This is running Backtrack 4. We're going to launch the terminal window down in the bottom left-hand corner. And first, we are going to run the ifconfig command. This is a command that you can use to check the IP address of your system, but what you're going to see here is that the Linux sniffer actually does not have either a private or a public IP address. And it's kind of one of the points of the lab is that the sniffer can somewhat reside outside of the network, but still capture the packets. So you'll see here it has this is a local loopback address and cannot be essentially found by other computers on the network. If we do ifconfig-a, this is going to list all of the available network adapters connected to this machine. And the ETH0 and ETH1, this is basically means the first network adapter, and then this is the second one. So you'll see on the lab PDF, the reason why there are two network adapters in this case is because it needs to capture packets on two different networks, the internal network and the external. Now also, to be able to capture packets through network analyzers, you need to set the network adapter into what's called promiscuous mode. So we can do that using ifconfig. So in this case, we are saying, okay, on the first network adapter, enable promiscuous mode. And we will do this as well for the second network adapter. Whoops. Great. And we also have to enable both adapters to the up condition. So we just do ifconfig ETH0 up. And speaking of up, I'm actually going to give you a quick Linux tip. If you press the up arrow, it's going to show you the last command that you entered. And you could actually just press your arrow key over, change that one little line so that we can put the other network adapter in the up position. And we can confirm this by typing in ifconfig ETH0. And now you'll see right here, this is up. And you can do the same with ETH1. You notice that is up. And if you remember from our previous command as well, you could always do -a, and that will actually show you both together. Great, so moving on. We are getting to the TCP dump stage. Good idea whenever you're exploring a new tool. On Linux, you can get help. So the --help will give you some of these options, which you'll find that we will be using in upcoming commands. And some other help areas that the lab doesn't get into just yet is manual pages. So if you on Linux, if you do man, M-A-N, and then the tool or command, it will actually open up essentially a manual for this. You can scroll to the next page by hitting spacebar, and whenever you want to exit that, you just hit the letter Q. All right, and then so the very first thing we're going to do, we're going to run tcpdump. We're going to do -i, which you can see here from the help that we got. This is selecting the interface, and we're going to say we want interface ETH0. So this is going to capture packets on this first network card. Give it just a moment. Okay, so we have some packets here. And actually, I'm kind of glad this happened because this lab can be a little bit finicky. Sometimes when I've done it, some packets weren't being generated. So actually what I did was I came to the Windows 7 attack machine, and all I did was I sent a ping to the firewall. And what this did, it generated packets. So it generated 4 ICMP ping requests. And this is something we'll get to in just a little bit in the lab, so it's kind of a little early stage on this, but it allowed me to kind of force some traffic, so that you'll see here, this is where we ran TCP dump. We're listening on this first network adapter, and we noticed that because it captured on this 192, and then if you go back to the topology, that is the internal network. So what you could tell by this is that the ETH0 is listening in on the internal network. So we could probably assume that ETH1 is going to be listening on this external network, and we can confirm that if we just hit Control-C. So whenever you start a capture with TCP dump, to end it, you just enter Control-C, and that is also detailed on the lab walkthrough. So let's try this again with TCP dump -I for interface and ETH1, and let's see if it picks up anything normally on the external network. Okay, and here we go. We have some packets here on ETH1 packet capture. Once again, it wasn't generating some packets automatically. So what I did in this case, which this is very good practice, I came to the external network. I opened the Windows 2K3 server machine. I sent actually just one ping to the firewall, and as you can see, it was actually timed out. So this is another a learning lesson here, most likely because the firewall is blocking ping traffic from external networks. So, but you could see that even though it was blocked, the packet sniffer, which remember is right here, it saw this machine attempting to connect to the firewall, to ping the firewall. So that's what we're looking at right here. It's saying, okay, this 10.10.19.202, which as you can see resides down here, .202 on the 1010. So now this is the confirmation we were looking for, that, okay, yes, ETH1 indeed is sniffing on this external network. Okay, great. Ready to move on to the rest. You can just hit Control-C there to stop that capture. Now we're going to go move into a more detailed TCP dump command. And you'll see here the lab outlines the uses of each of these options very well. So let's type that in. -NNTTTT. What we're doing here is we're actually saving the capture into what's called a PCAP file, and that is where you can actually open this PCAP file into an application like Wireshark. So I'm going to let that capture. The lab says to let it go for about 5 minutes, but real quick I will go over these options that we used. So -I from before, you should be familiar now, that's selecting the interface. -NNTTTT disables DNS resolution, date, and time format. The -S0, it's going to disable the default packet size, which is normally 96 bytes. You'll see at the end here, we are actually designating it to be it captures in 100 byte packets. And the -W stands for write, so we're going to write to this capture file, capnet1.pcap. So I'm going to let this run for a second, and I will be right back with the results. Okay, so I let that run for a few minutes. Could have potentially let it run for maybe a minute or two more, but you can see here it captured 7 packets. Good enough for us to take a look at here now. So you'll see the next part of the lab, we are going to launch this PCAP file with Wireshark. And so you'll see this is a graphical interface where TCP dump is strictly command line. So a lot of people obviously prefer Wireshark. You can also capture this with this, which we will in just a little bit. But you can just see here, it looks like it didn't pick up any IPv4 connections yet, but it did pick up some IPv6 information here. So it's mostly all that the lab is wanting to point out at this point. So we'll keep moving on. And then it does also want us to capture the same way, but on ETH1. So what I'm going to do, I'm going to press the up arrow a couple times. I'm going to pull up that previous command and move over, change this to ETH1, and go ahead and hit enter and let that go. And you'll see here that's also outlined on the lab as well. So I will be right back again and let this capture some packets. Okay, looks like we have 4 packets to look at here. So I'm going to do Wireshark capnet2 pcap. Go ahead and open that up. And so we have a few things to look at here. We could see that, and this is actually me. Once again, I was trying to force some packets just to make sure that some data was being generated. I was pinging the firewall again from the Windows 2K3 server here. So what we're looking at here is actually an ARP request, or I'm sorry, excuse me, a ICMP ping request from that machine. So we can go ahead and close that, and we will. Now this is the part of the lab that we will get into pinging some more. So we should be pretty good on that concept now. So we want to make sure we are on the Windows 2K3 server internal machine, which is going to be up top here. So in Windows, when you ping a host, it's going to default to only sending 4 ping requests. But what we want to do for this lab is we want to send a continuous stream. So let's, in this case, you're going to see we are pinging the firewall. So remember this .1. It's always nice to just come in back and double check the topology. So you see this .1 here. And this -T option, this is going to tell Windows to just continuously keep pinging this IP address. So let that keep running. And then we're going to come back to the Linux sniffer. And we're going to go back into tcpdump. And because this is running on the internal network, we know we need to use the interface ETH0. And this time we're going to tell it we only want to see ICMP packets. These are what the protocol that the ping command is using. So you could pretty much see these instantaneously. This is live. If we went back to the Windows machine that is sending out these ping requests, we can see those coming in each second at a time through tcpdump. So I'm going to hit Control-C to stop that. I'm going to come back here, also hit Control-C to stop the ping. And now let's try pinging one of the external machines. So we'll do ping 10.10.19.148-T for continuous ping. So you see that's moving. We'll come back to the Linux sniffer. Once again, if you don't memorize the VM numbers, you could always come back to the topology, click the Linux sniffer. And since we know that the ETH1 interface is for the external network, we're going to capture the packets on that interface. And so you could see them coming in live once again. So I hit Control-C there. I'm going to come back to the Windows machine, stop the ping with Control-C. And so that completes the first part of this lab. So moving on to the second part of the lab, we will be using Wireshark to actually capture, where before we used tcpdump. So let's come back to the Linux sniffer. We still have both network adapters in the up permission, and so all you have to do to launch Wireshark is just type in Wireshark in your terminal. You can also access it from the menu. So if you come to like backtrack, I believe information gathering, or no, network mappings. Forgive me, I haven't used backtrack in a while. It's in here. I'm not going to keep going, but it is accessible through there. You could also probably just very simply search for it down here. Yeah, see that launches it there. But for launching in a terminal, something I want to note when you launch an application in the terminal, you see if you close this, it would also close the app. So that's something to keep in mind as well. So I'll just go ahead and relaunch that from the terminal as the lab suggests. Okay, so within Wireshark here, we can also set this to capture interfaces, just like we chose within tcpdump. So if you go to capture interfaces, the first part of this lab, we're going to be connecting from the Windows 7 machine and FTPing into the Windows 2K3 server. So we're within the internal network, and we know that that runs on ETH0. Now, one thing I noticed while going over this, the lab document, if you're following along with that, on this part, it incorrectly tells you to choose ETH1 at this part. You want to make sure this part, you want to select ETH0, since we are monitoring on the 192 internal network. So I'm going to select start on ETH0, and you can see up at the very top it says here ETH0 capturing, and we're already getting some IPv6 solicitations here. But what the lab wants us to do is come into the Windows 7 internal machine, and actually you can see here I attempted to do this and learned of the issue. So let me exit out of here. Okay, so we're going to enter in FTP. Let me get to the part of the lab here. FTP 192.168.100.201, which, as a reminder, that is the Windows 2K3 server. Oops. Okay, so hit enter. It's going to ask you for a username. The lab shows us that the username is FTP, and the password is mysecurepass, which is most definitely not secure, but you know, easy for the lab. So you see here, anonymous user logged in. So we had a correct login. If we come back to the sniffer, I'm going to maximize this and bring this down. Nope, can't bring that anymore. What the lab is wanting to point out is you can actually see these FTP packets, and what you'll learn about FTP, file transfer protocol, is that it transmits in plain text. So it's not super secure. In the future, you'll learn about SFTP that runs, that uses SSH to make it more secure of a transfer. But in this case, you see here, okay, we got an FTP request, users FTP, and another request is, okay, there's the password, mysecurepass. So in this case, this is kind of an example if I was in a malicious attacker and I was sniffing in on a network. You sometimes, if you're not using a secure method of login, this is where passwords can be found. So we'll go ahead and hit the stop button on this capture. And another thing it points out here, general Wireshark usage, you could search for particular packets. So I'm searching for the FTP protocol here, and obviously that looks a lot cleaner if this is what I wanted to focus on. Another thing to look at here is just these columns going across Wireshark. You have the number of packet, depending on how many the total. In fact, here, let me take off this sorting, and you'll see that they are in order. So I go 1, 2, 3, 4, 5, and you have as many as 23 packets total here. And then the time is, in this case, it's related to, looks like in seconds of when these packets occurred. Very high frequency packet captures, they could be broken down as little as milliseconds or even smaller. Here you have the source IP, or in this case, this here is an IPv6 address. In destination, you have the destination IP address. So you could see here the .5 made a request. The Windows 7 machine made a request to the Windows 2K3 machine here. And then you have it sorted by protocol, and then the info is just more info, which is where we were able to see the username and password. So it looks like the next part we're going to monitor on the ETH1 interface. Pardon my dog in the background. So to do this, we will come to which machine here? We're going to come to the backtrack 4 external machine, because remember ETH1 is capturing on the external network. So we'll click on the backtrack 4 machine. Let's go ahead and open terminal. And so so far we've just been pinging from Windows, but keep in mind it's exactly the same in Linux. Or, I'm sorry, we're not pinging at this point, we're FTP connecting, but also very similar. So we'll do FTP 10.10.19.22. Name, again, FTP. And on this case, so it actually looks like we're connecting to, okay, so in this case, we're connecting from the backtrack 4 machine to the Windows 2K3 server, so all within the external network. And the password in this case is super secure. And you'll see here user logged in, so that's a success. And then we come back to the Linux sniffer, and now you'll see all of this traffic here. You have the FTP request, user FTP, and you have the password super secure. So same as last time. And that concludes part 2 of this lab. And we'll keep moving on. Okay, so coming to the final section, section 3 of lab 1. We're going to be capturing and analyzing traffic with Network Miner. This is a Windows tool, very similar to Wireshark in ways. So we're going to be using the Windows 7 internal attack machine. Go ahead and close this. You'll find Network Miner on the desktop. And we're going to go ahead and select the network adapter that we'll be using. So we choose the socket Intel R Pro 192.168.100.5. We'll go ahead and hit start here. And it wants us to open Windows Explorer. I imagine Wireshark would work, but I'll keep it to the lab here. And we're going to connect to another machine. So 192.168.100.201. This is the Windows 2K3 server. So you'll see that's just a very, very basic test index HTML page. But you'll see here it captured a lot of that, not a lot, all of that traffic. We're going to visit another server, which is going to be the Red Hat Linux server, and it's probably running a very basic page. So you see here that this is a test page. This generally means that the server hasn't been fully set up yet. So this can sometimes be a security flaw that an attacker might look for. He might assume, oh, maybe there's a default password that hasn't been changed yet. So we're going to come back to the network miner. We're going to go ahead and stop. And we're going to click on the Files tab. And so you're going to see that, let me go ahead and maximize this. So it actually captured, the index file. And if I double click on that, maybe not double click, I need to right click and open file. So if I go back here, you'll see that the difference, while they look the same, the difference is that this one is we're still connected to the server, whereas this is actually on our hard drive now. So it downloaded it into a network miner folder, assembled files. So this is a way that you can just kind of hoover up a bunch of web traffic, and you could actually log that. Then you'll see here it also captured the visit to the Red Hat Linux site as well. And then next, we could even see that it pulled images. So any website that's visited while this capture is being run, all of the HTML files, images, sessions, all of these things are all captured. So that concludes Lab 1, Network Devices and Technologies, Capturing Network Traffic. In this lab, we went over tcpdump, Wireshark, both network analyzers, how to use a Linux, or not just Linux, but a sniffer in general, residing across networks to running multiple network adapters to sniff traffic on both sides. Hope you enjoyed, hope it helped, and thanks for watching.